Hi, I'm Rob Moir. I'm the Executive Director of the Ocean River Institute. And I came by that with a PhD in Environmental Studies from Antioch, New England, where I was a Switzer Fellow. Prior to that, I earned a Master's of Science in Teaching, and I'm certified to be a high school and junior high and elementary teacher, and I have taught. And I got all that degree from Antioch, New England as well. And then prior to that, I have a Bachelor's of Education from Hampshire College. I've also had the good fortune to study at the Marine Biological Lab in Woods Hole. So my particular field is environmental preservation, environmental policy work, and we're advocating, and I was drawn to that field in two ways. One, I was in high school for the first Earth Day in 1970, and second was the work of Rachel Carson and how she brought her nephew Roger down to the coast and wrote this wonderful essay called A Sense of Wonder. And Carson's books have been an inspiration for me, so that the Ocean River Institute get its name, or we have our name, from Rachel Carson's book, The Sea Around Us, where she writes, "All at last returns to the sea, to Oceanus, the ocean river, like the ever-flowing stream of time, the beginning and the end." So Carson is drawing upon Homer in the Iliad, talks about Achilles having his shield, and forged on the shield was the ocean river around the edge. And so the Ocean River Institute is about protection, but it's also about systems thinking, where we don't have to worry about the boundaries of the world of the seal and the otter or the osprey, where one ends, the other begins. It's all one big system, and we have to respect, as Carson taught us with her Silent Spring, that there's much permeabilities to the boundaries of these realms, and that we have to be holistic in talking about all of it. The Ocean River Institute was founded in 2007, and we are reaching out to educating individuals about ocean, river, and watershed, the whole system, issues and opportunities where they can make a difference. At the Ocean River Institute, we are communicating with decision makers, and whether they be in Washington or on Beacon Hill or at the town level, where we learn about opportunities to improve the environment, the oceans or the rivers. We find out what they like to do about that, and we bring it out to constituents. And so we have many people who are in touch with us by email, and we explain the issue, and then we ask them to comment. So we're the only organization that brings together comments, diverse comments, a cacophony of different voices, to the decision makers. And this they are really grateful for, because they never hear from their constituents except for the top 3 issues, and those are pretty ossified in people's opinions. And so when they're at the committee working level, it's just really great to hear the different perspectives, because we have found the more diverse the input, the more robust the solution, and the more ownership the people have in following through with the practices and keeping the whole thing going. If you visit the Ocean River Institute's homepage, you will see 6 different campaigns, opportunities where you can lend your voice to different issues. And I want to talk with you about just one of those today, and that involves addressing 3 of the world's greatest problems. And the dastardly trio are, number 1, if we have too much nutrient pollution and nitrogen and phosphorus coming off the land that is being eaten by algae that blooms and eats up the oxygen and can create ocean dead zones. So in Boston Harbor, we had striped bass chasing menhaden, and they swam into the Mystic River into an ocean dead zone where there was no oxygen, and they all died. So we want to address that problem. The second problem is we have a loss of natural habitats. We need to have natural spaces, and so that's a huge problem, is the loss of natural areas which provide space for diverse wildlife, and it's tied to our quality of life. And then the third big issue is, of course, climate change, global warming. I'd like to tell you about the Natural Lawns with Healthy Soils for Climate Restoration Challenge. This is a friendly competition between towns to see which town can have the highest percentage of homeowners pledging or volunteering not to put fertilizer on established lawns. We're only talking about established residential lawns. Starting one is a whole other problem, but the established ones, and we're also just kind of educating people that lawns get a bad rap for polluting and for needing lots of water. And that's because we're putting the fertilizer on, quick release fertilizer on top, and that mostly gets washed off. So the grass plants, when it's over fertilized, are on the surface. The roots are on the surface because they don't have to go into the soil. The food's right there, you know. And so they keep the plants apart because the grass, the roots, they're taking up space. And so that leaves dirt patches, and that bakes and compacts and becomes what we call sun spills across your lawn. And only the toughest of weeds will grow in there. And then the grass that did green up quick is really wimpy because it lacks the nutrients that should be fed to it through the soil. So you've got this wimpy grass with sun spills, and the fertilizer company will say, oh, your lawn wasn't prepared for the winter. We didn't get to look under your turf and do an oil change for you, or whatever it is that you're supposed to do to your car. Well, this is a natural system. So they'll say, hey, we can repair this. We've got the technology for this, which is to overseed, which means we'll punch holes in the hard packed stuff and we'll spread seed. And because you've got weeds, we'll spread herbicides. And because you've got pests, we'll do pesticides. And it's like you got this vicious circle. So the solution is, if you got a lawn, don't put the fertilizer on. And instead, the grass is developing symbiotic relationships with the fungi in the soil down below, the mycorrhizal network. The second problem is the loss of nature. You know, we have less wild habitats, less places for rabbits and wildlife to enjoy, you know, less clover around because the lawn's been fertilized. So in Springfield, Massachusetts, University of New Hampshire researchers looked at 16 lawns there, and they cut the grass weekly and every 2 weeks and every 3 weeks. So they had 3 sets of lawns, and they didn't water the plants. And when they cut the grass, they left the cuttings on the lawn, and they came back and they found that the grass lawns that had been cut every 3 weeks had 63 species of bees that were inhabiting it, and they found that 36 different kinds of plants were in between the grass blades, like clover and horseweed, all kinds of 36 different kinds. And then they looked at the lawns that were cut every 2 weeks, and they found 94 species of bees. So apparently bees, like a greater diversity of bees, prefer grass shorter than cut every 3 weeks, but cut every 2 weeks. And what's remarkable is that so much wildlife can be there. They found that most of the bees are solitary bees, so you don't have to worry about hiding bees when you cut the lawn. And many of them were limited to their whole life cycle in the lawn. So we see great wildlife value when we just stop leaving the chemicals on it. So our goal in the Natural Lawns with Healthy Soils Challenge is we're going town by town, and well, Boston's a big town, and so Boston has the emerald necklace that Olmsted designed that connects all the green parks with green pathways around the city. So we're trying to create in Rockport here today, we're calling for emerald bracelets where the different lawns that are natural can become wildlife corridors for the wildlife of Rockport. So the third step is to slow and reverse climate change, and we're going to do that by looking right at the microclimates, you know, the immediate around us, because the largest greenhouse gas of all is water vapor. And so we can do much to help our water cycle. And the plants play an active role in that. So the plant stomata, the little openings in the plant deliberately opens its stomata and lets vapor out. On a hot day like today, the vapor will evaporate, and it cools the microclimate. So if I'm standing under a tree, it'll feel cooler than standing in the shade of an awning or the shade of a building because of evaporation. And then conversely, at the coldest hour of the day, which is an hour before dawn, the darkest hour, again, the plants deliberately open their stomata and release water vapor, which then condenses, and it releases heat as it's forming dew to slightly warm before the sun comes up. So if we can have more vegetation, we can modulate our local climates. The best builders of soil are the grasses, whether it's salt marsh grasses or prairie grasses or eelgrass or turtle grass, even the lowly lawn grass. Nothing as much as the grasses pulls carbon out of the atmosphere, carbon dioxide, and puts so much into the ground. When a grass plant pulls 8 tons of carbon dioxide out of the air, it'll photosynthesize and manufacture plant material and liquid carbon, that is carbohydrates, that it pumps out of the roots to feed the fungi, which in turn feed everything else in the system. So this is an amazing way to get carbon out of the air and into the ground. If you step on a plant, it stimulates it to repair itself. And the fungal strands are so thin, the hyphal strands reach into the plant cells and touch every cell. And so the injured plant cell can put a signal, an enzyme, into the mycorrhizal web, we call it the wood wide web, and say, I need some more nitrogen, I need a little this, I need a little that. And the bacteria at the end of the web gets the signal and puts it back into the web that transports it back to the plant, and not just that plant, to all the plants. So if the plant feels a need for thickening its walls, they all get the opportunity to pick up the enzymes that help to encourage that. So natural lawns are a great way to draw down carbon, and then the carbon in the ground is eaten by animals and crunched up and processed, the carbohydrates. And there's a chemical process of moving the organics and the minerals into a thing called humus. And humus is very stable, it's very nutrient rich, but it'll hold the carbon for thousands of years. And so we talk about grasslands and humus, and soils rather, of being long-term carbon storage, whereas forests and wood is short-term because it lasts only hundreds of years. And so we want to have both. In fact, the best way to capture the most carbon is called silvopasture, which means you have trees surrounded by grass, and so you've got everything going. So by having a lawn and walking on it, you are increasing your climate change, you're increasing the capture of carbon and the storage of carbon, and helping with fighting climate change. Research has indicated that the more vegetation we can have, and the deeper the soils can be, the less runoff we have from septic and sewage and stormwater, that we can reduce sea level rise by 25% locally. So it's really important that we value our lawns for being carbon storage places. In summary, natural soils don't pollute, so they stop the formation of harmful algal blooms if we just not put fertilizer on it. They provide forage and wild spaces for a great diversity of animals, especially bees. And finally, they are active actors in slowing climate change by drawing carbon out of the atmosphere and storing it long-term in the ground. I invite you to visit our website, www.oceanriver.org. And when you get there, you'll see opportunities to subscribe to our e-alerts, and that'll keep you updated with stuff that's happening. I also invite you to take a look at the 6 different challenges and pick one of them and learn about it and write down some comments, because I guarantee you, your voice will be heard. We have the communications with the decision makers, and you're talking to what they want to know about. So please visit our website. I want to thank you for stopping by the shore here and being on the cutting edge and spending some time with the Ocean River Institute. I hope you will take what you have learned today and share it with other people. And please take care of yourselves, and let's take some care of this planet of ours. Together we can.